Hi guys, today we're going to learn how to convert, evaluate, and change the base of logs. So we'll talk about simple logs and the natural log today. So with converting, all right, we know obviously that exponentials and logarithmic functions are closely related, but why? Well, one of the reasons is they are inverses of each other, so they're definitely related to each other in that. Another reason is they can be written in the same form, or a similar form. We can convert them. So when we see log base 2 of 16 equals x, it's really asking 2 to the what power gives you 16? And we can answer that question, and that answer is 4 there. All right, log base x of 27 equals 3 is saying x to the third power is 27. So what's x? What to the third power is 27? And that, of course, is 3. Log base 2 of x equals 4 is really asking 2 to the fourth power gives you what? And 2 to the fourth power gives you 16. If you remember from last class about graphing, all right, a common log has base 10. So if you just see the word log with no number in this spot, we assume it's base 10. And your natural log, or ln, so your natural log, is base e. And that e number was also given to you last block. It's about 2.71828. It goes on forever. It's like pi. It's an irrational number that goes on forever, also known as Euler's number. All right, so let's look at this whole converting thing first. All right, so our conversion rule is we are going to swing the base. All right, so here is logarithmic form, and here's the exponential form. These are equivalent to one another. You can go back and forth between the two forms. So to do that, we swing the base. So notice your base is always located here on a log. So if we swing it over here, now it's at the bottom. This e is my now exponent, and it's equal to the n number that was inside of that log. All right, same thing with exponential form. All right, if you started with a base e, you're going to swing it over here, and now it's going to become the base of your log. So it's log base b, n is still in the same spot, and the e is now the answer. All right, so both ways it works. So let's convert some and let's practice here. So these should all be on your note sheet. Feel free to pause at any time if you want to try it yourself, and then press play when you're ready. So we want to convert the following expressions to their equivalent forms. So obviously the first first 3 are in exponential form, so we want to convert them to log forms. We're going to swing the base. So this base comes over here. So now it's going to be log base 9 of 81 equals 2. All right. You should remember from your good old Algebra 2 days, those wonderful rational exponents, right? This index becomes the denominator of my exponent, so it's going to be 8 to the 1/3. We also reviewed those rules a few classes ago, so those should be fresh in your mind. So this is the same as 8 to the 1/3. So our base is 8. So it's going to become log base 8 of 2 equals, whoops, sorry about that. Edit, gonna undo my move there. It decided to move on me for some reason. Edit, undo, edit, undo. All right, let's go back. So 8 is our base, so it's going to be log base 8 of 2 equals 1/3. For the next one, we have 4 to the negative third power equals 1/64. So we again swing the base, so we're going to swing that 4 over, so it's going to be log base 4 of 1/64 equals -3. All right, now the next 4 are already in log form, and we're going to convert them into exponential form. I actually find this a little bit easier. So you see the base, swing it over here. So this says 4 to the 4th equals 256. For the next one, you should get 2 to the 5th equals 32. Now, for this last one, or next to last one, it's a common log because there's no number right here. But remember that number is 10. So we're going to swing that 10 over here. So it'll be 10 to the 1st equals the number inside, which is 10. All right, and then the last one is a natural log. Remember, you're not going to see a number down here, but we know it's base e. All right, so if we swing that over, watch this, it's going to be e cubed equals e cubed. Well, that's kind of a duh. All right, so now let's work on, sorry, these are just more practice on converting. I apologize. It might have even been some of the ones that we already did. I'm not sure why there's an extra slide of that. All right, so let's move on to evaluating. All right, so we are going to evaluate these ones without a calculator because they're pretty simple. You know, based off of our ability to convert. So if we say log base 3 of 9, remember that's 3 to some power equals 9. Well, 3 to the second power equals 9, so our answer there is 2. Log base 4 of 64, remember that's 4 to what power gets you 64, and we should know that that answer is 3. The next one's kind of fun, well, depending on your definition of fun. Log base 2 root 2, you need to remember, okay, that the square root of 2 is the same thing as 2 to the 1/2. So basically this is saying 2 to what power equals 2 to the 1/2? Well, I wonder, it should be, sorry about that, it jumped on me again. It should be 2 to the 1/2 power. So 1/2 is your answer there. All right. Now, whenever you see fractions in your spot here, all right, think back to Algebra 2 days, also to when we went over those rules, all right, that means your exponent is going to be negative, okay, because we're asking 2 to the what power equals 1/4. Well, we know that 2 squared is 4, so to get to 1/4, it's got to be 2 to the negative 2. So our answer here is going to be -2. All right, 3 to what power equals 1/81. All right, again, it's a fraction, so we know it has to be a negative exponent, but just think about 3. 3 to what power is 81? 3 to the third power is 81, so this is going to be the negative third power, or sorry, negative fourth power. I apologize, it's been a long day, my bad. -4. All right, and then log base 5 of 1/5, that's going to be -1. All right, because 5 to the negative first power is 1/5. We know 5 to the first power is 5. So when it's a negative exponent, it's a fraction answer. All right, so what about if they're not so simple? That's when we need to use a calculator or Desmos, or even our smartphone can handle this. If you turn it on its side, it becomes a scientific calculator. Poof, blow your mind. All right, so this is known as the change of base property. So this is something you need to memorize, just like the conversion rule is something you need to memorize. So when we see log base b of n, that can be rewritten as log of n over log of b. Notice that these are now base 10, which is what your calculator defaults to. All right, the same process works for ln. Again, your calculator has ln on it as well, which I'll show you in just a moment. So we want to evaluate these with, sorry, it says without using a calculator. Oh, it just repeated itself. I apologize. Or no, it didn't. I apologize. It should, it's just an error in my slides. You have to use a calculator here. So we're going to evaluate using our change of base property. All right, so let's start off. We can rewrite all of them first of all. So log of 15 over the log of 2. And we're going to just put that into our calculator. So just give me a moment here. I'm going to open up my calculator. All right, so you might be using a calculator like this at home. And if you're not, I'll show you on Desmos here in just a moment. All right, so you should notice that there's this button that says log. You hit it. You put in 15, close the parentheses, divided by, and then hit log 2. Close parentheses, hit enter. All right, and you get this beautiful number right here. All right, and we're going to round to 3 decimal places. So we're going to say our final answer is 3.907. All right, you're more than welcome to finish doing the rest and check your answers with me in just a moment. All right, now the other thing that we can do is use Desmos. All right, Desmos is free. Okay, so if you go to the Desmos app or just to Desmos and hit start graphing, this will come up. All right, if you click functions on your keyboard and go over to miscellaneous, all right, you have log as an option. So you can click log, you can type in 15, then you can put divided by, you can just use the division sign, you can use the backslash on your computer, either way is fine, or on your phone, and then log base 2. And you notice we get the exact same answer, that 3.907. So that's pretty simple. If you have any questions on how to use either the calculator or Desmos, feel free to ask in class. All right, I'm going to finish the rest of these by just kind of giving you the answers now that we know how to plug them in. So log of 25 over the log of 4 has a final answer of 2.322, and then the log of 27 over the log of 8 has a final answer of 1.585. Again, I rounded these to the nearest third decimal place. Please bring your questions to class, and I look forward to helping you out.